Okay, now let's proceed to the next item. Please add this restriction that our g is defined over 0 to 2 pi because sine x is a periodic function. It might have infinitely many critical numbers. Now, to find those critical numbers, we need to differentiate this function with respect to x. And that will be sine 2x over 2's derivative is cosine 2x, right, times the derivative of what's inside. By chain rule, we have 2 for the derivative of 2x all over 2. Okay, plus the derivative of sine x is cosine x. Now, this will cancel out, so we have cosine 2x plus cosine x left. Now, the critical numbers are the zeros of this function. Hence, to find the zeros of this function, or cosine 2x plus cosine x, we equate them to 0. And we solve this equation involving trigonometric expressions or functions. So we have, at first glance, it seems that this equation cannot be solved by a factoring or by transposing to the other side, and probably the best way is to recall trigonometric identities related to double measures. So recall that cosine 2x is the same as, this is cosine 2x, not cosine squared x. So lagyan natin. This is a double measure. So cosine 2x is equal to cosine squared x minus sine squared x, or it can be a 2 cosine squared x minus 1, or 1 minus 2 sine squared x. If you can't recall this, kahit ito lang yung alam mo, then palitan mo lang yung cosine squared or sine squared ng identities. So since we have a cosine here, probably this is the best choice we have. So I can change this to 2 cosine squared x minus 1 plus cosine x equals 0. And as we can notice, this is an equation which is quadratic in form. So for you recall in algebra, for you to visualize it even clearer that this is in quadratic form, we can represent cosine x as another variable, say a. Then this equation becomes 2a squared plus a minus 1 equals 0. And this is the left hand side is factorable. We have a 2a minus 1 and an a plus 1. Okay, so this equation becomes a 2. Let's bring back the original variable, 2 cosine x minus 1 times cosine x plus 1 equals 0. And this implies that two things can happen. It's either 2 cosine x minus 1 is 0, or cosine x plus 1 is 0. Or in other words, cosine x is 1/2, or cosine x equals negative 1. Since we have the restriction that x should be taken from 0 to 2 pi, let's think of an arc length such that cosine of that arc length is 1/2. Recall that in a unit circle, cosine is 1/2 at pi over 3 and 5 pi over 3. Okay, so in here, x must be pi over 3 and 5 pi over 3 in the interval 0 to 2 pi. Then for cosine x equals 1, cosine of an arc length is negative 1 when it is in the negative x axis. So meaning x must be in in pi. Okay, so we have 3 zeros of g prime of x. Are they all critical numbers? Yes, since they are part of the domain of g, which is 0 to 2 pi. Actually, the domain of g is r if it has no restriction, but since we are only dealing with critical numbers in 0 to 2 pi, they are indeed defined on our functions, in our function. Hence, we have 3 critical numbers, namely pi over 3, 5 pi over 3, and pi. So the next thing we need to do is to create a sign table. Okay, as before, to create our sign table, we need to line up our critical numbers in increasing order. So we have pi over 3, then next is pi, next is 5 pi over 3. Okay, and we put our g prime of x here, g prime of x here, and take note that g prime of x, as we have obtained a while ago, is this one, cosine 2x plus cosine x. Is cosine 2x plus cosine of x. Okay, then these spaces here can be interpreted as the intervals before and after those critical numbers. So you can opt not to write it down just for visualization. This interval and clarification is from 0 to 2 pi. 0 to pi over 3. Sir, bakit hindi na lang negative infinity to pi over 3? Again, this is periodic in nature and we are restricted to find x in 0 to 2 pi, in the closed interval 0 to 2 pi. And this is the open interval pi over 3 to pi. This is the open interval pi to 5 pi over 3. This is the open interval 5 pi over 3, closed chi 2 pi. If ever nagkamali kayo ng lagay ng pagkaka-increasing order, magkakamali yung intervals na makikreate ninyo. Okay? Again, let's put down solid lines here to denote that they are defined on the derivative. Now, let's pick a number between 0 and pi over 3. This is 0, this is pi over 3. Since we're dealing with arc lengths, it is better to pick special angles in between them. So in this case, pi over 6 is a nice choice. So if you pick a number here, say g of pi over 6, g of pi over 6 is cosine. Let's change this to pi over 6. 2 times pi over 6 is pi over 3 plus cosine of pi over 6. Cosine pi over 3 is positive and cosine pi over 6 is positive. They are square root of 3 over 2 and 1/2, meaning this is positive. Meaning at this interval, this is positive. Okay? Next, at between pi over 3 to pi, let's choose a number. Say an arc length, say pi over 2. If you evaluate g prime at pi over 2, we obtain cosine of 2 times pi over 2 is 2 times pi over 2 is pi plus cosine of x is cosine of pi over 2. Okay, what's cosine of pi? Cosine of pi is negative 1 and cosine of pi over 2 is 0. And this is a negative number. Right, so meaning this interval it is negative. Next, let's pick a number between pi and 5 pi over 3. 3 pi, this is pi and this is 5 pi over 3. And this special angle might be the best to use. That's 3 pi over 2. So it's g prime of 3 pi over 2. That is cosine of 2 times 3 pi over 2 is cosine of 3 pi, right? Plus cosine of 3 pi over 2. Okay? What's cosine of 3 pi? 3 pi is coterminal with pi, right? So cosine of 3 pi is negative 1 as well. And what's cosine of 3 pi over 2? Cosine of 3 pi over 2 is 0. And that's a negative number as well. So meaning in this interval, the derivative is negative. Lastly, from 5 pi to 2 pi, what is the sign of the derivative? Let's pick a special number, special arc length, say 11 pi over 6. So what's g prime of 11 pi over 6? We have cosine of 11 pi over 6 times 2. That is 11 pi over 3, right? Plus cosine 11 pi over 6. And that is, where is cosine 11 pi over 3? Cosine 11 pi over 3 is, 11 pi over 3 can be rewritten as 6 pi over 3 plus 5 pi over 3, right? Meaning, 11 pi over 3 is 2 pi plus 5 pi over 3. This means that 11 pi over 3 is 5 pi over 3 after one full revolution, meaning it is coterminal with 5 pi over 3. So what is cosine of 5 pi over 3 now? This is the same as cosine of 5 pi over 3. Cosine of 5 pi over 3 is 1/2, and cosine 11 pi over 6 is square root of 3 over 2. And that is indeed positive. Let's erase this first. This is positive, meaning over this interval, we have positive derivative. Now, we are now ready to make conclusions. Okay, so let's delete this part, right? First, we need to identify when is the function increasing and decreasing. So g is increasing whenever the derivative is positive. So for these parts, 0 to pi over 3 and 5 pi over 3 to 2 pi, g is increasing. So g is increasing on 0 to pi over 3. Will this be an open or a closed interval? Well, this should be a closed interval because our function g is continuous on pi over 3. And it's also increasing over the interval 5 pi over 3 to 2 pi. Again, closed interval because f is continuous at g is continuous at 5 pi over 3. Same goes with the next set of conclusions. G is decreasing whenever the derivative is negative over those intervals, which happens on pi over 3 to pi and pi to 5 pi over 3. Okay. Next, where are the relative extrema of this function? You can notice this critical number. The derivative before it is positive, which means that before pi over 3, the function is increasing, then after pi over 3, the function is decreasing. Hence, g has a relative maximum at x equals pi over 3. And lastly, g has, what do you think? Notice that at this critical number, before pi, the function is decreasing, and after pi, the function is decreasing as well. Hence, if we look at its graph, probably it looks like this. Hence, we have no relative extrema here by the FDT. So let's go to 5 pi over 3. Before pi over 3, the function is decreasing, right? Then after 5 pi over 3, the function increases. Hence, there must be a relative minimum at 5 pi over 3 at x equals 5 pi over 3. Okay.